So up to last class, we have started chapter number 1. Chapter 2 of Unit 1, which is dimensional analysis. We've already completed like we were making list of quantities. What was the last quantity that we have discussed? Tomorrow we'll try to finish this topic. What was the last quantity that we had discussed? Serial number. Formula. Specific heat. Dimensional formula. SI unit and series. Okay, the last quantity was specific heat, 14. So it's serial number, physical quantity, then formula, then dimensional formula, then dimensional formula, then finally SI unit, and then CGS unit. That's it. So after specific heat, the next quantity is quantity number 15. The next quantity is frequency. See, frequency is 1 by time period. So 1 by time period means its dimensional formula would be T minus 1. The SI unit of frequency is seconds inverse or hertz. CGS is second inverse. So this is frequency. After frequency, the next quantity is Planck constant. The next quantity is Planck constant. We can calculate Planck constant from this equation. Planck constant can be calculated. Fatma, frequency, the formula of frequency is 1 by time. Frequency is 1 by time, so its dimensional formula would be, it's 1 by T1. If you take this T in numerator, it would be T minus 1. If you take this T in numerator, it would be T to the power minus 1. So the SI unit is 1 by time, it's second inverse or hertz. Fatma, is it clear now?
Yes, sir.
The next is after frequency, the next is Planck constant. E is equal to h nu, where E is energy, nu is frequency, and this h is Planck constant. So you can write your h as the ratio of E and D. This is h, which is ratio of E by D. Noor, what is dimensional formula of energy?
Sir, mass L square and T raised to minus 2.
Yes, 1 L squared T raised to the power
Minus 2.
minus 2. And what about frequency, Noor?
Frequency Time inverse. Time raised to minus 1.
Frequency is T1, right? So combine
M
right?
L raised to 2. T raised to minus 1.
No, it's going to be minus 3. It's minus 2 and 1 will come to numerator. It would be minus 2 minus 1. So this is M1 L square T minus 2. Units. Energy is joule. Frequency is second inverse. So that's joule seconds. If I consider CGS unit, it would be erg seconds. SI unit is joule seconds. After applying constant, the next quantity is, let's say, electric current. The next quantity is electric current. Fazil, is electric current a fundamental quantity? Fazil.
No.
Yes. Current is fundamental. It's one of the 7 fundamental quantities.
Oh yeah, sir.
Its dimensional formula is A1, or you can simply write this as I1. You can either write this as A1 or I1. Some authors may use I1 for it. SI unit is ampere. CGS unit is watt. This is CGS unit of current. Next, we need electric charge.
सर
Yes.
सर प्लैंक कांस्टेंट में t -1 होना चाहिए ना डायमेंशनल फॉर्मूला ये फ्रीक्वेंसी
frequency T-1.
Oh, sorry. Yes. Sorry. By frequency is yes, T minus 1. So it would be T to the power minus 2 plus 1. Yes, right. It would be minus. Thank you. The next is electric charge. Fazil, what's the relation between current and charge? This was in class 10 syllabus. Relation between current and charge. Fazil. Janvi, relation between current and charge. Yes, Abdullah, you are correct. Relation between current and charge.
Electric current into time is equals to electric charge.
So current is charged by time. So you can write your charge as current into time. Hamda, what should be the dimension formula of charge?
सर I
I is A1 and time is T1, right?
T1 yes sir
SI unit is 2. Okay, just note it down.
सर
Yes.
सर इलेक्ट्रिक चार्ज का CGS फॉर्मूला नहीं होगा
CGS, we usually don't use CGS quantity, but the CGS is ESU, electrostatic. No one will ask CGS of charge, but this is electrostatic unit, ESU. There is one more name of this unit, which is stat coulomb. Either stat coulomb or ESU. It's either stat coulomb or ESU. This is CGS.
Sir, Planck's constant के आपने क्या लिखी है? Unit?
Unit or dimension? Unit?
सर आपने Planck's constant की SI unit क्या लिखी है?
Joule seconds. It's joule seconds. Joule seconds. Abdullah, this is stat coulomb, or you can write this as ESU, electrostatic unit. You can write this as either stat coulomb or electrostatic. That is for electric charge. Stat coulomb or ESU, electrostatic. So shall I rub it?
Yes, sir.
Yes, sir.
Noor, Fazil, Abdullah.
सर सर ये CGS यूनिट क्या है इलेक्ट्रिक चार्ज की?
Stat coulomb or ESU, electrostatic unit. Okay, the 19th quantity is potential. You can write this as either potential, or you can say this is EMF, or this is voltage. The formula is it's work done divided by charge. Now first calculate the dimensional formula, report your answer in chat room. Calculate the dimensional formula and report your answer in chat room. Potential, EMF or voltage formula is work done divided by charge. It's work done by charge. Okay. ML squared T minus 3 A minus 1. Shabaz is correct. Janvi, you're missing something in L. Noor, just check your time, dimensions of time. Abdullah is correct. Fazil is correct. Noor, just check your dimensions of time. Hamda is correct. Fatma, check your dimensions of time. And we always write this in order like mass, length, time, then current. We always write this in this order. First mass, length, time, and then current. Hamda. Okay. Yes, no, now you are correct. Shafaq, yes. Sania, Sania Fatma, Mariam,
सर EMF की फुल फॉर्म क्या है?
electromotive force. Basically, EMF of cell like 10 volt, 20 volt cell, that's electromagnetic. So the ratio of work done and charge. Work done is it's M1 L square T minus 2 divided by charge, which is A1T. So the combined is M1 L square T minus 2 minus 1 over A minus 1. So this is M1 L square T minus 3 A minus 1. SI unit is good. We won't study CGS in these cases. Only SI is enough. M1 L square T minus 3 A minus 1. The next is after potential. Okay, just calculate the dimensions of resistance. Resistance is simply the ratio of voltage and current. It's simply the ratio of voltage and current. The ratio of voltage and current is resistance. Calculate the dimensions of resistance from this expression. It's V by I. Calculate the dimension of resistance and report your answer in chat room. Okay. Right. Janvi is correct. Abdullah is
सर पोटेंशियल का क्या था फॉर्मूला? आपने बोला था मेरा गलत है तो सही क्या है?
m1 L square T minus 3 A minus 1. It's m1 L square T minus 3 A minus 1. Right.
सर आप प्लीज लिख दीजिए.
This is potential, na Janvi. This one is potential. This is potential. M1. This one. M1 L square T minus 3 A minus 1. This is dimensional formula of potential, which is work done by charge. Resistance is the ratio of voltage and current. Voltage is M1 L square T minus 3 A minus 1 over current. Current is A1. So this is M1 L square T minus 3 A minus 2. So this is it. M1 L square T minus 3 A minus 2. This is resistance. And the SI unit is ohm.
सर आपने ये वोल्टेज का कैसे लिखा है?
Voltage from this step 19. Potential, EMF, voltage all have same dimension. Their dimensions are M1, L2, T minus.
पोटेंशियल डिफरेंस.
Yes, voltage, potential difference are same quantity.
यस सर.
Shall I rub it? One last quantity. Then we'll start the applications of dimensional analysis. Shall I rub it? Noor, Fazil, Alina.
Yes, sir. Yes, sir.
Yes, sir.
Okay. The next is using this relation 1 over 4 pi epsilon naught Q1 Q2 over R square, where F is force.
एक्सक्यूज मी सर.
Yes, Jani.
सर आप जो भी लिख रहे हैं ना वो मेरे को दिख नहीं रहा है. मतलब आप लिख रहे हैं उसके बहुत देर बाद नजर आ रहा है.
अभी एक बार लॉग आउट करके लॉग इन करो. तुम्हारा इंटरनेट कनेक्शन बहुत वीक है, इसलिए हो रहा है. एक बार लॉग आउट करके लॉग इन.
ओके.
Abdullah, yes, dimension of energy is m1 L square T minus 2, right? So this is force 1 over 4 pi epsilon naught Q1 Q2 by R square, where F is force, Q1 Q2 are charges, R is separation, calculate dimensional formula for epsilon naught. You're supposed to calculate dimensional
सर
formula.
आर के आगे क्या लिखा है आपने?
R is separation, which is length basically. Get the value of epsilon naught. Yes, 4 pi, 4 pi. See, 4 and pi are pure numbers, they are dimensionless. Epsilon, it's a constant. You're supposed to calculate dimension of this constant. The name of this is epsilon. Calculate the dimension formula of this epsilon. It should hardly take 1 minute. Should hardly take 1 minute, not more than 1 minute. Answers. M minus 1, L minus 3, T4, A square. Okay. Okay. Okay, let's take the calculations. So if I cross multiply this equation, you will get your epsilon naught it's simply Q1, it's Q2 over 4 pi R square multiplied by. This is Q1, Q2 by 4 pi R square. Now we substitute the dimensional formula. Q1, Q2 are charges. So charges are simply A1, D1. Q2 is again charged. 4 and pi are just numbers, so they are dimensionless. R is length, that's L1 square. F is force, with 1 T minus 2. So the combined is, it's A square, T square over, it's M1, L
सर
Yes.
सर आपने क्या कराया उसके बाद रेजिस्टेंस के बाद एक बार बता दीजिए.
Just this question. This is the next question.
अच्छा ओके.
So in denominator, this is M1, this is L square and L1, so it will be LQ. And this is T to the power minus 2. So the combined is, if I take this M in numerator, this will be M to the power minus 1. Then you have L to the power minus 3. Then this is T. This is 2 minus of minus. Then you have A square. So the combined is, it's M minus 1, L minus 3, T to the power 4, A square. This is the value of epsilon. M minus 1, L to the power minus 3, T to the power 4 into A square. This is the dimensional formula of epsilon. So,
सर ये आर क्या लिखा है आपने? सुपर क्या लिखा है सर?
R is separation. R is separation of charge. Separation is.
ओके.
So Mariam is wrong. Shafaq, M minus 1, L minus 1. It should be L3.
Okay, sir.
Wrong. Abdullah. Yes, Abdullah is correct. Hamda is correct. Noor is correct. Mariam Yahya wrong. Fazil Shahbaz incorrect. That's it. Now, Fazil Shahbaz is correct. M minus 1, L minus 3, T4 A square. Great. So any doubt in this particular task?
सर ये 4 पाई कहाँ चला गया?
Is number. 4 pi is number. So number doesn't have dimension. Numbers are dimensionless. This 4 and pi don't have any dimension. They are debit.
अच्छा ओके
Shall I rub it?
Yes, sir.
एक्सक्यूज मी सो am I audible?
You are audible. Yes, Jan.
Yeah, so on 3rd of September, it's my UT of physics.
Janvi, let's discuss it after the class. We'll discuss it after 4:30.
Okay, sir.
Nishkarsh have told me. We'll discuss it after the class. Okay?
Okay, sir.
Okay, let's rub it. So that was about writing dimensional formula. So once you have any formula, I'm sure that you can write dimensions of any quantity once you know the formula of that particular quantity. After this dimensional formula, the next is types of quantities on the basis of dimensions. So types of quantities on basis of dimension. Basis of dimension. On the basis of dimension, you can divide quantities into few categories. Like, first of all, you can divide your quantities into two categories. Your quantity could be constant or it could be variable. Whatever physical quantity we deal with, it's either a constant or a variable. Like acceleration due to gravity, it's a constant quantity or a variable quantity?
Constant.
It's constant.
Constant.
Speed of light, it's a constant quantity. Speed of light's value,
Constant. Yes, sir. 3 into 10 is
simple velocity, it's a constant or a variable? If I
Variable.
velocity is have any value, but if I say speed of light, and that speed of light is a constant quantity. First of all, we can divide quantities into two categories. It could be constant or it could be variable. Next, we can further divide these constants into two categories. Your constants could be dimensional, means constants which have dimensions, dimensional constant. Then you can have dimensionless constants. Dimensionless constant. So these constants actually they don't have any dimensions. In the same way, you can divide your variables into categories. Like you can have dimensional variable. Is a variable which have dimension, or you can have dimensionless variables, means variables which don't have any dimension, or you can have dimensionless variable. So on the basis of dimensions, we can just divide quantities into four categories. It's dimensionless constants or dimensionless constants. Dimensional variable means variable quantities but having dimensions. Or you can have dimensionless variable, means variable quantities that doesn't have any dimension. Let's start writing examples of these quantities. If we say dimensional constants, constants having dimensions, examples are speed of light. Speed of light, which we represent by c. Speed of light is a constant, but it have dimensions, dimensions of speed. Acceleration due to gravity. Fazil, what's representation of acceleration due to gravity?
Small g.
Yeah, this is small g. It's again a constant, but it have dimensions. Planck constant.
H.
Yes, h. It is a constant, but it have dimensions. The next you have dimensionless constants. These constants doesn't have any dimension. For example,
Why?
number. If we take numbers, each and every number is constant itself, but they doesn't have any dimensions. Pi, if I take pi, pi is a constant but doesn't have dimension. Angle is variable. So these are examples of dimensionless constant. These are constant values but they doesn't have any dimension. The next are dimensional variable. Means quantities which are variable and they have dimensions. Examples include like speed. Speed is a variable quantity. Speed could be of 10 meter per second or 10,000 meter per second. It's a variable, but it have dimension. After speed, let's say you have force. Force is a variable quantity, but it have dimension. You can have energy. You can have current. The maximum number of quantities are under this category. This category have maximum number of quantities. Almost all the quantities are variable and they have dimension. There are very few quantities which are variable but dimensionless. For example, if I say refractive index, you must have done in class 10. Refractive index is ratio of speed by speed. It's the ratio of speed in vacuum to the speed in medium. So it's a variable. Different mediums have different refractive indices, but it's a dimensionless quantity. After refractive index, you can have strain. Strain is a variable quantity, but it's dimensionless, simply dimensionless. Then you can have angle. Angles are variable, but they are again dimensionless. In the same way, you have coefficient of friction. Coefficient of friction, we represent it by B. It's ratio of two forces. It's again a variable quantity. Different mediums have different values of coefficient of friction, but it is dimension. So on the basis of dimensions, we can just simply divide quantities into four categories. Either they would be dimensional constant, dimensionless constant, dimensional variable, or dimensionless variable. Is it clear up to this point?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Noted, then we'll move on to some principles.
Done, sir.
So, shall I rub it? Fazil, Dullah, Noor, Hamda.
Yes, sir.
Yes, sir. Done.
Let's rub this thing. The next is principle of homogeneity of dimensions. The next is principle of homogeneity of dimension. All applications of dimensional analysis are based on this simple principle. The simple principle of homogeneity of dimension. This principle says, it's a very general concept that if you are adding mass, can you add mass to velocity?
No,
Sir.
Can you add mass to velocity?
no, sir.
No, sir.
Add mass to mass only.
Yes, sir.
Can you add length to time?
No, sir.
No, sir.
Yes, sir.
Always add length. time mass with mass. So we always add quantities which have same dimensions. So this principle simply says that quantities having same dimensional formula can only be added or subtracted. Can we multiply quantities having different dimensional formula?
Yes, sir.
No or yes?
Yes, sir.
Yes, sir.
You can always multiply quantities having different dimensional formula. This is how we make new quantities. Like area is length into breadth. So on multiplying length and breadth, we get area. But can we add two different quantities like area and length?
No, sir.
Sir.
Can we multiply area and length?
Yes, sir.
And the quantity would be volume. Multiply an area and length, the final quantity would be volume.
Volume.
So quantities having same dimension formula can only be added or subtracted, but is there no such restriction on multiplication and division? The same result can be written in one more way. It can be written as that dimension of quantities on both sides of equation are same. So if you take an equation, then dimensions of quantities which are on both the sides of equation are exactly same. For example, let's say we have mass. We can add mass to mass and the end result would be mass only. So to the left of this equality sign, the dimension formula is m1. To the right of this equality sign, the dimension formula is m1. So whenever you have equality in your equation, the quantities, the dimension of quantities to the left of equation and the dimension of the quantities to the right of equation are exactly same. This is a simple principle of homogeneity of dimension. One more example. If I'm adding m1 with m1, like mass with mass, you will get mass, dimension formula is m1. Don't write this as 2m1. Dimensional formula is qualitative, it's not quantitative. Don't write this as 2m1, just simply write it as m1. m1 plus m1 is it. That's it. Similarly, you can say that m1 minus m1. If you're subtracting mass from mass, you will write this as m1. Although magnitude could be subtracting mass of 2 kg from mass of 2 kg, you can get a mass of 0 kg. But eventually you will get some mass. This is qualitative. If you add mass to mass, you will get mass. It doesn't matter whether that mass is of 2 kg or of 0 kg. If you're subtracting mass from mass, you will get mass. It doesn't matter this is of 0 kg. These things are qualitative. Similarly, if you're subtracting length from length, you will get length. It's not mathematical in this way that I cancel this L and L, I say it's 0. This is qualitative. This simply says, I'm subtracting length from length and the answer would be length. Whatever may be the magnitude of that length be of 2 meter or could be of 5 meter. Magnitude could be any, but the thing will be length only. So is it clear? These 2 points.
Yes, sir.
Yes, sir.
Yes, sir.
So never write m1 minus m1 equal to 0. It's always m1 minus m1 equal to m1. Never write L1 minus L1 equal to 0. It will always be L1 minus L1. Noor, Fazil, is it clear? Last 2 properties, last 2 examples. Fazil. Okay. The next is, let's say I write this equation A plus B equal to C. Now, can you just compare the dimensions of A and B? If I'm writing A,
सर m1 plus m1 2m1 क्यों नहीं हुआ?
2 magnitude होगा जानवी. Dimensions में magnitude matter नहीं करता. It's like mass plus mass is mass. That mass could be of
Okay, sir.
A plus B equal to C. If I'm writing A plus B equal to C, the dimensions of A, dimensions of B, and dimensions of C all are equal. So I can simply write this as
A plus B is equal to
dimensions of A is equal to dimension of B, which is equal to dimension of C. I will use this concept in numericals. If you are adding two quantities, they should have same dimensions. And dimensions of quantity to the right side of equation is again. If I write this as A plus B is C plus D. Janvi, can you compare dimensions of A, B, C and D?
सर एक्चुअली आप जो लिख रहे हैं ना वो उस टाइम पे नहीं आता है, वो बाद में आ रहा है.
Okay, अब देखा.
So A plus B is equals to whatever.
A plus B is equal to C plus D. A plus B is equal to C plus D. Yes, Janvi, is it clear now? No.
So एक बार फिर से बता दीजिए, आपकी वॉइस भी क्लियर नहीं आ रही है मुझे.
A plus B is equal to C plus D. So can you compare the dimensions of A, B, C and D? If this is the equation that A plus B is equal to C plus D. Yes, Janvi, we are adding A to
All their dimensions would be same.
be same, right? So dimensions of A would be equal to dimensions of B would be equal to dimensions of C, which is equal to dimensions of D. All A, B, C and D will have exactly same dimensions. The next is, okay, if I write this as AB plus CD equal to EF. Now, does A and B should have same dimensions or they can have different dimensions?
They can have different dimensions.
A, B can have different dimensions. What about C and D?
Same, so different.
Different dimensions. Similarly, E and F can have different dimensions. But what are the dimensions of A, B and C, D?
They are equal.
Same, so same.
Excuse me, sir. So if A and B can have different dimensions, then why have you written that dimension of A is equals to dimension of B?
No. I'm writing A and B can have different dimensions if you are multiplying them. Can you see this particular equation, this AB plus CD equal to EF?
So आपने A plus B is equals to C plus D लिखा हुआ है ना?
AB plus CD is equal to EF. चैनल में तुम्हारा इंटरनेट कनेक्शन बहुत इशू कर रहा है, लैग बहुत ज्यादा. अब दिखाइए.
Yes, so अब दिख गया. AB plus CD is equals to EF.
Equal to B. So if you are multiplying A and B, then A and B can have different dimensions. So you can say that you can't compare the dimensions of A and B actually. C and D could have different dimensions, E and F could have different dimensions. But what about AB and CD? You're adding AB and CD, or you are subtracting AB and CD, they will have same dimensions. Similarly, CD and EF, they will have same dimensions. So dimension of AB is equal to dimension of CD is equal to dimension of EF. So I will use these 3 points in numericals. Just note it down. Then we'll start numericals and applications.
So मैं एक बार लीव करके दोबारा आती हूँ. आप प्लीज ये वाली स्लाइड में बताइएगा, मैंने लिखा नहीं है अभी ये.
Okay, Janvi. ठीक है अब्दुल्ला, ओके कर लेंगे. Okay, it's one more thing. If I'm writing y equal to sine x, I'm just writing y equal to sine x. Can you decide the dimensions of x? What should be the dimension of x? If I'm writing y equal
सर
to
वो तो एंगल है ना,
yes, so that means
डायमेंशनलेस होता है ना एंगल.
so if I'm writing y equal to sine x, then this x is an angle,
Then it is dimensionless.
and this angle would be dimensional. Clear? If I'm
Yes.
sine
Yes, sir.
x is an angle, it should be dimensionless. Similarly, if I'm writing y equal to sine of a plus b, if I'm writing sine of a plus b, then what about a and b? If I'm writing sine of a plus b,
Sir, it is again dimensionless.
sine
Yes, sir.
is different for angle. So these a and b both are angles. You can say
Yes.
that a are angles. Both a and b are angles. If you're writing y is sine of a plus b, that means both a as well as b are angles, and if they are angles, then they should be dimensional. Just like sine, if I write y equal to log x, then what is this log x? Log is always defined for number. This x is a number. Log, we always define log for a number. X is, and the number is dimensionless. We always define x for a number, and number is always dimensionless. So here again, if you are writing log of something, then that term is dimensionless. X is dimensionless. This x is a dimensionless form. Please note it down a little bit.
Sir, done.
Okay, the next is So these are three applications of dimensional analysis in your syllabus. First is checking the accuracy of formula. Second, derivative of formula, derivation of formula, and third one is conversion of one system of unit into another. All three applications are based on same principle of homogeneity of dimension. All these three applications are based on the same principle. Just put it down, then we'll start with the first thing. Note it down, we'll start with the first application.
Done, sir.
Fazil, Sania, Noor.
Yes, sir.
So the first application is conversion of one system of unit into another. Checking the accuracy of formula. Let's start with checking the accuracy of formula. This checking the accuracy formula, simple application of principle of homogeneity of dimension. You just have to satisfy principle of homogeneity of dimension. Principle of homogeneity of dimension. Principle of homogeneity of dimension. Checking the accuracy. So the first is, let's start with a numerical. So you have this relation, t is 2 pi root over L by G. You have to check whether this formula is correct or not. Check accuracy of this formula. You have to check accuracy of this formula.
So t is equals to 2 pi under root.
Over G. L is length and G is acceleration due to gravity.
And t is time.
T is time.
Okay.
T is time period, which is actually a time. L is length and G is acceleration due to gravity. And G is acceleration due to gravity. So you just have to check whether this formula is correct or not. To check the accuracy, first start with left hand side. On the left hand side you have t, dimension of t is t1. T is time period, its dimension is in t1. Then we will start with right hand side. At the right hand side you have 2 pi root over L by G. So you will write the dimensions of 2 pi root over L by G. Let's check it, Abdullah. It's 2 pi root over L by G. 2 and pi both are dimensionless constants, so they doesn't have any dimensions. So you are left with root over L. L is length, L1. So you can simply write this as dimensions of RHS. RHS is this, 2 pi is dimensionless. It's root over L. L is length. Dimensional formula of length is L1. G is acceleration due to gravity. So the dimensional formula is L1 t minus 2. So the combined is, it's root over L1 divided by L1 means 1 minus 1. This t to the power minus 2 will come to numerator, it would be t square only. So this is L to the power 0 t square. This L to the power 0 is dimensionless. So this is root over t square. That means it's just t. So the dimensional formula is just t. So dimensions of LHS is equal to dimensions of RHS. So where LHS and RHS have same dimensions. So dimensions of LHS is equal to dimensions of RHS. So here both LHS and RHS have same dimensions. If they have same dimensions, that means formula is dimensionally correct. Formula is Dimensionally correct. It can be wrong. It's just dimensionally correct. It can be wrong due to these constants. Remember, dimensionally, we can just check whether your formula is dimensionally correct or wrong. A dimensionally correct formula could be wrong due to constant. In actual formula, this is 2 pi. Instead of 2 pi, if I say it's 5 pi root over L by G. See, dimensionally, this is correct or wrong? This 5 pi root over L by G.
It's correct.
Correct.
Dimensionally, this root over 5 pi root over L by G is again correct.
Yes.
For L by G, because dimensions doesn't depend upon 5 pi. It's dimensionally correct, but actually it's an incorrect formula. In the correct formula, you have 2 pi. Instead of 2 pi, you are using 5 pi. So the formula is wrong, but dimensionally it will comes out to be correct. That's why using dimensional analysis, when we check accuracy, we never write that formula is correct. We always write that formula is dimensionally correct. Clear?
Yes, sir.
Yes, sir.
Janvi, Fazil, is it clear?
Yes, sir.
Okay, just note it down.
तो ये अभी आपने फर्स्ट वाला ही कराया ना, चेकिंग एक्यूरेसी.
Fazil, shall I rub it?
Yes, sir.
Sure. Let's move on to next. Okay, the next formula is say you have frequency is 1 by 2L. It's root over T by L. Here L is length of string. L is length of string. T is tension. Tension is basically a type of force. M is mass per unit length. M is mass per unit length. Mass per unit length. And nu is frequency. So using this, just check the accuracy of this formula. Check whether this formula is correct or not. Check accuracy of formula. You know dimension of each and every quantity. And remember, it's not mass, it's mass per unit length. Check whether this formula is dimensionally correct or not. Okay, it's wrong. So Fazil says it's wrong. What about the rest? Hamda, Mariam. It's mass per unit length. It's mass per unit length. No, dimension would not be m1. It will be m1 by l1. It's not just mass. It's mass per unit length. Mass by length. Answers. Hamda, Fatma, Sania, Shafaq.
Sir, wrong.
Wrong. Okay. Noor. Mariam says it's not correct. Alina says it's incorrect. As far as I remember, it's a correct formula. And you people are making mistakes in this M. You're making mistakes in M. Say, left hand side is frequency. So dimensions of LHS is only T minus.
Yes.
In right hand side, you have 1 by 12 root over T by M. If I write dimensions, then dimensions of RHS comes out to be, it's 1 by, then 1 is dimensionless, 2 is dimension, it's length only, it's L1. It's root over T. T is tension. Tension is force, which is M1, L1, T minus 2.
Minus 2.
Divided by small m. Small m is not mass. Small m is mass per unit length. Small m is mass divided by length. So its dimension should be dimension of mass divided by dimension of length. So it's m1 L minus 1. It's a very common mistake in this question. It's not just length, mass. It's mass per unit length. So it's m1 L minus 1. Is it clear this m?
Yes, sir.
Yes, sir.
Yes, sir.
M is mass per unit length. So that's 1 by L1. It's root over. M1 will cancel this M1. L minus 1 will be the numerator. It would be L square. Then you have L square T minus 2. If you take root, this is 1 by L1. If I take root, root means power gets half. So this L square will become L1. T to the power minus 2 will become T minus 2. Root means the power get half. So L1 will cancel this L1 now. And you are left with only minus 1. So this formula is correct. Dimensions of LHS. Yes, only Abdullah got the right answer. Is equal to dimensions of RHS. So all of you were making mistakes in this M. I'm writing it that M is not just mass, it's mass per unit length. Is it clear now? Shafaq?
Yes, sir.
Yes, sir.
Clear?
So the formula is dimensionally correct.
Yes, it's dimensionally correct. It is dimensionally correct. So shall I rub it?
Sir, wait.
Yes, sir.
Yes, sir.
There's one last question on checking the accuracy. That is,
Sir, done.
so I'm rubbing it. The last question is, you have this expression, dn is u plus a by 2, 2n minus 1. dn is displacement covered in nth second. Displacement covered in nth second. It's not just displacement. This is basically, when I say nth second, that means this is displacement by time. So dimensions won't be L1, dimensions will be L1t minus 1. U is initial velocity. Noor, what are the dimensions of initial velocity? Noor?
L1 T minus 1.
Yeah, good. L1t minus. Here A is acceleration. A is simply the acceleration. And this n is this nth second. Here n is the nth second. So that's basically time t1. Here 1 is 1 second. Even this 1/2 dimensions now, it's t1. It's not number 1, it's basically 1 second. Okay, now check the accuracy of this formula. Check accuracy of this formula. I have written each and every dimension. See whether this formula is correct or not. Check accuracy of this formula, whether this formula is correct or not. Fazil is saying it's correct, okay? Amda, Alina, Janvi, Sania, Shafaq. It's correct or not? Fazil got the answer that it is dimensional. Correct. Amda says it's correct, okay? Solution. So if I write dimensions of dn, this formula is dimensionally correct only if dn, u and this quantity have same dimension. So dimensions of dn are L1 t minus 1. Dimensions of u are, u is velocity, it's L1 t minus 1. Then you need dimensions of a by 2, 2n minus 1. So a is L1 t minus 2. 2 is a number. This 2 is number. N is time. So that's t1 minus 1 is time. This is t1. So Shafaq, can I cancel this t with t? Shafaq.
सर मुझे ये समझ ही नहीं आया, मैं पूछने वाली थी ये a/2 के बाद वाला बता दीजिए.
जहां मैंने पूछा वहां पूछने वाली. So this is acceleration. The dimension formula of acceleration is L1 t minus 2. 2 is just a number. Number is dimensionless. So 2 will not have any dimensions. Next, this is bracket. I am writing dimensions of quantities in the bracket. This 2 is a number. Number is dimensionless, so no dimensions for 2. This n is time. This n is time. So the dimensions of n is t1. Minus this 1. 1 is time, its dimension are t1. So Shafaq, again, can we cancel this t1 and t1?
No, sir.
Yes or no?
No.
They will not cancel. T1 minus T1 would be T1 only. So the combined would be L1 T minus. So all three quantities have same dimensions. So you can say that formula is dimensionally correct. Formula is dimensionally correct. So this is a dimensionally correct formula. Any doubt in this?
No, sir.
No, sir.
We just note it, then we'll rub this question.
सर ये n की वैल्यू सिंपली t1 and
n is, so its dimension is simply t1. N is time, dimension is t1. So I'm rubbing it, okay? There's one more type of questions on the same application on checking the accuracy of formula. In this application, instead of checking the accuracy of formula, you would be given that formula is correct. You have to calculate unknowns from that formula. For example, let's say I'm writing this formula that m plus x equal to y, where m is mass. Calculate dimensions of x and y. Now the formula is there are
Sir,
two
आपकी voice
unknowns
clear
in
नहीं
this
है.
equation. If this is mass, then what should be x?
Mass.
Mass.
You can add mass to mass only. And what about y?
Mass.
The mass.
You can add to mass, and that result should be mass. You can say that dimensions of x is equal to dimension of y, which is equal to dimension of m. So you can say that dimension of x is equal to dimension of y, which is equal to dimensions of y. That's a simple example. In equation, you can have one or more unknowns. To calculate those unknowns, you will use principle of homogeneity of dimension, that if a formula is dimensionally correct, you can add or subtract only those quantities which have same dimension. Let's say I write one more example. Like this is a plus, or it's at plus b root x. Here f is force, t is time, x is position. X is position means x is length. Calculate dimensions of A and B. Calculate dimensions of A and B. You have to calculate the dimensions of quantity A as well as quantity B. Now, if this formula is correct, that means F, AT and B root x should have same quantity. Agree?
Yes, sir.
Yes, sir.
Yes, sir.
AT and B root x should have same dimensions. So I can write this as dimension of F is dimension of AT. So what is dimensions of F? Force.
MLT minus 2.
F1 L1 T minus 2. A is unknown. Is an unknown constant. What about T?
T.
T1.
Time T. So from here you can calculate the dimensions of A, which are M1 L1 T minus 2 divided by T1. So dimensions of A are, it's M1, it's L1, it's T minus 3. So these are the dimensions. Similarly, we can calculate dimensions of B. So can we equate dimension of F with B root x?
Yes, sir.
Each of the individual quantities, this F, this A root, AT and B root x should have same dimensions.
Yes, sir.
We'll compare dimensions of F with that of B root x. You can say dimension of F is dimension of B under root x. So dimensions of F are M1 L1 T minus 2. B is a constant. X is length. This is L1. So this is M1 L1 T minus 2. T. Root means power is half. I can write this as L to the power half. Is it clear? Under root means power is half. So that is L to the power
Yes,
half.
sir.
So you can calculate B. Your B will comes out to be, it's M1 L1 T minus 2 over L to the power half. So here B is, it's M1 L to the power. 1 minus half is half, T to the power half. Is it clear?
Yes, sir. Yes, sir.
In this way, you can calculate the values of unknown from an equation. Write this, then we'll do one more very quick. Okay, one more numeric. I'm just rubbing the question. That's a very important question. P plus A over V square, V minus B is equal to R. Where P is pressure, V pressure, the dimensions of pressure are M1, L minus 1, T minus 2. V is volume, L cube. R is gas constant. T is temperature. Calculate dimensions of A and B. You're supposed to calculate dimensions of A and B. There's one hint in this question, and the hint is no use of R and T. Don't worry about the dimensions of R and T. Even without R and T, you can calculate the dimensions of A and B. Calculate and report your answer in chat. Get the dimensions of A and B and report your answer in chat. There's one more hint. Always pick terms having addition and subtraction. Like first pick this one, V minus B. So V and B should have same dimension. Also pick this one, that P plus A by V square. P plus P and A by V square should have same dimension. Yes, Fazil, you are correct. Fazil, just check your calculation of dimensions of A ones. You're making mistakes in A. B is correct, but A is wrong. Yes, Abdullah. Abdullah is correct. Fazil, just check your calculations. You're making mistakes in A. V is volume, not velocity. Yes, Abdullah, you're correct. Yes, Fazil, no, it's fine. Noor, Sania. Yes, Mariam, A is correct. Yes, Alina, B, dimension of B is correct. Now calculate dimensions of A. Mariam, first, no.
सर गलत गलत टाइप हो गया ऐसे बोलो ना
Right. V minus B. So if in this V minus B, if you're subtracting V and D, that means V and D should have same dimensions. So I can just write this as dimensions of V is equal to dimension of B. V and B should have same dimension. V is volume L cube. So B is L cube. Almost all are having correct answer for B. But many
yes, sir.
mistakes in A. Say P plus A by V square. That means P and A by V square should have same dimensions. Dimensions of P equal to dimension of A by V square. Dimension of P is M1, L minus 1, T minus 2. A is A and V is L cube square. So you can write this as N1 L minus 1 T minus 2. It's A by L to the power 6. So this A is simply M1 L minus 1 T minus 2 into L6. If you multiply, this is M1 L5 minus 2.
सर यही था आंसर.
So this is the dimensions of A, M1 L.
Yes.
So is it clear now? V is volume.
Yes, sir.
Yes, sir.
Even in lengthy expression, just try to find terms which are either in addition or in subtraction. Those terms will simplify your calculations. So this is about checking the accuracy of formula. Okay, I will share an assignment in your batch based on the topics that we have done today. Fazil, Noor, I have shared an assignment with you people. Assignment with proper answer key. Yes, the same assignment, Abdullah. फातिमा मुझे नंबर भेजो अपना व्हाट्सएप करो.
सर सर आपने बोला था कि आप संडे को सुबह क्लास लेंगे 10 बजे या 9 बजे आपने बोला था सर वो एक्स्ट्रा क्वेश्चंस कराने के लिए.
पे डाल दूंगा कल होगी या नहीं होगी ग्रुप पे डाल.
ओके सर थैंक यू सर.
So Abdullah, Fazil and Noor, I have shared an assignment in your group of dimensional analysis. Just try to solve this assignment. Okay, let's stop here. We will continue this class tomorrow at the same time. I need just half an hour to complete dimensional analysis. Tomorrow we'll continue with errors.
थैंक यू सर. अल्लाह हाफिज सर.
Thank you, sir.
Fazil and Abdullah, please wait. I have to discuss some time. Noor, Fazil, Abdullah, please wait. I have to discuss some timings with you. Other can leave.
So, my UT.
Janvi, I'm just calling you within 10 minutes. Okay?
Sir.
I should leave now then.
You can.
Sir, I should wait or should I leave?
You can leave, Janvi. I'm just calling you within few minutes.
Okay.
Sania, what is your school name? Sania. You're not audible. Okay, you are from IHL. So, your schools are reopening from 2nd Sep, right?
Yes, sir.
And what was the topic that your teacher was doing in class 11th physics?
Laws of motion.
Laws of motion.
You have any upcoming exams?
Sir. No, sir.
No.
Only tests are going on.
Sorry?
Tests are going on.
Tests are going on. They are going on. Okay. So can we have some extra classes in weekdays?
Okay, sir.
In morning,
Which day?
just
Which
a
day, sir?
comfortable time in morning when I can have some extra class. I'm going to keep some extra class for the next whole week so that we can complete this as fast as possible. I want to complete this dimension error up to vectors by the end of coming week. What's your preferred timings in the morning?
Sir, which 12:30 or 12:30? This one only.
12:30 would be fine. Can we make it in the morning, like according to your timings? Can we have a 1 hour class at 9 a.m.? Will that suit you?
No problem.
Sir, according to our time, your time.
Your time. I'm just talking in terms of your time. 9.
Yes, sir, sure.
Yes, sir.
Fazil, Abdullah, Noor, Sania.
Yes, sir. It's fine.
Fine.
Yes, sir.
Okay, so tomorrow we have class at the usual time, like it's according to you, that's 12:30, right? Yeah, it's 12:30 as per your time.
Yes,
So
sir.
we have class at 12:30 p.m. But after Sunday, for the whole week, from Monday to Friday, I will take 1 hour class daily from at 9 a.m. as per your timings. We'll try to cover maximum part of sleep as far as we can.
But sir, Wednesday our school will start, I guess.
Okay, so what's the timing of school? It's 9 a.m. Na?
No, sir, it's
8.
8 to 11.
It's 8 to 11.
Yes.
Okay. So then we can keep it at 11 or 11:30.
Okay, sir.
We take early morning too. If 7 a.m. is comfortable, if you are comfortable with 7 a.m., then we can have class at 7 a.m. 7 to 8 before your school. Or it would be too early. Yes, Anya. Fine, or it would be too early. Sanya, I couldn't hear you.
Sir, 11:30 will be fine, sir. 7 is too early.
Yes, sir.
So let's keep a class on Monday at 9, Monday and Tuesday at 9 a.m. From Wednesday onwards, we'll keep it at 11. So the next 2 to 3 weeks, I'll try to finish as much as possible, 3 to 4 chapters. Okay? And I'll keep on sending assignments in the WhatsApp group. Solve those assignments and send solutions to Nishkarsh. I'm just sharing his number in the group. You have to submit your assignment with him.
His number is there, sir. Like,
So just WhatsApp your solutions to him, not on the group. Like personal messages to him on the WhatsApp. He take care of all assignments. Basically, we will make a monthly report card. On these monthly report card, even your marks of assignments, your marks of class performance, is someone who is counting the number of answers given by you. Even in the software, people count the number of answers given by you, number of correct answers, number of questions that you have raised. So the monthly report card would be a very detailed one. So for that report card, I need submitted assignments. To submit those assignments to Nishkarsh. I'm just,
okay, sir.
the number of questions in dimensional analysis are too much. There are almost 30-40 questions. You don't have to solve all questions. I'm just texting the number of questions that you have to submit it to Nishkarsh, then 10 to 12 questions. Okay. So by tomorrow, I will complete dimension analysis. So up to Tuesday, you can submit your assignment to Nishkarsh. Then I will share for errors and keep on sharing.
Okay, sir.
Meanwhile, if you have any school test, if you have school tests, you want extra classes, then just text me over this number. If I am available, I will take extra class. Otherwise, there are more faculties. They can help you in your school exams. If you have a school test or something, which we haven't covered in class, you need some time, just text on this number. This is my number.
Okay, sir.
Okay, bachcho. Thank you. Bye.
Oh, doubts.
Yes, Abdullah.
डाउट पूछ लो सर। वो जो कल आपने जो क्वेश्चन करवाया था वो S is equal to UT plus half AT square वाला, सर आपने उसमें मतलब वो टाइम पीरियड वाला समझ में नहीं आया था मुझे। मतलब जो A to G वाला लेते हैं हम लोग, वही समझ में नहीं आया था। उन्होंने बोला था कि B to G से कैलकुलेट करो A to G वाला, मतलब जो फॉर्मूला था वही थोड़ा सा समझ नहीं आता।
अच्छा चलो, मैं ना तुम्हें वो जैसे तुम करना चाह रहे हो वैसे करके दिखाता हूँ, फिर तुम्हें दिखेगा कि अच्छा वो रिलेशन एक्शन में जादू है। ये यहाँ से फेंका था 10 से, ये ए था, ऐसी था ना अब्दुल्ला?
जी सर।
ये बी तक गया, बी पर फाइनल वेलोसिटी कितनी थी? 0। फिर ये
यस सर।
मैंने कहा था ग्राउंड तक आने का टाइम, तुम मुझसे कह रहे हो ए से बी का टाइम लेते हैं, फिर बी से जी का टाइम लेते हैं, राइट?
नहीं सर, मतलब उन्होंने बोला था कि B से G का टाइम कैलकुलेट करो ना, तो वो कोई
मतलब टोटल जर्नी में टाइम मींस ए टू बी, बी टू जी, टोटल जर्नी का टाइम चाहिए अब्दुल्ला, ए से बी से जी।
ओके सर, टोटल जर्नी, ठीक है सर।
अब हो जाएगा या भी करूँ उसको? यही कंफ्यूजन था या अभी भी कंफ्यूजन है?
सर मेरे को लगा B to G से कैलकुलेट करना है, इसीलिए मैं कंफ्यूज हो रहा हूँ।
पूरी जर्नी का, ए से बी, बी से ए। अरे एक तो उस बैच में इतनी कचर कचर करते हैं ना बच्चे की, बस नई नई बैच ऐसी होती है। अच्छा
सर
हाँ, तुम्हारे स्कूल में टेस्ट वेस्ट फिजिक्स का हो रहा है?
सर होते रहते हैं।
मार्क्स आ रहे हैं?
जी सर, ले रहा है, परफॉर्म करेगा, मतलब समझ आया था क्लास में तो कर लेता हूँ, थोड़ा बहुत डेफिनेशन भी लिख लेता हूँ।
अच्छा तुम्हारे टेस्ट कैसे होते हैं? न्यूमेरिकल्स अच्छे देते हैं या फिर सब डेफिनेशन बेस्ड?
सर हमारे टेस्ट मतलब न्यूमेरिकल्स होते ही नहीं है, मतलब जैसे कि मतलब क्योंकि ऑनलाइन होते हैं ना, तो सबको पता है